So in order to make it a little bit easier in terms of starting A-level chemistry, I thought it'd be useful to go through a few key concepts that you really do need to have firmly in place before you start. So this is useful if you're going from GCSE to A-level, but it's also useful vision for any A-level students on GCSE students as well, just to make sure they do understand these concepts. So we start with atoms. Now, as we know, everything is made up of atoms. And it was at one time we thought that the atom was the smallest particle that you could get. And now we know that atoms can be split, of course, and you remember the structure of the atom containing protons, neutrons, and electrons. But for chemists, we do not take apart atoms. All we do is we rearrange atoms to make new compounds. So we don't get involved with dealing with the nucleus, in terms of protons and neutrons and changing that. All we're interested in is how electrons are arranged. So the structure of the atom, this is the solar system structure of the atom, which we use for GCSE, and it just shows how it is made up, and hopefully you remember that in a nucleus are protons and neutrons, and that's where most of your mass is, and orbiting around the nucleus are electrons. Protons are positive, electrons are negative, and neutrons do not have any charge. So you may remember atoms are generally empty space because the nucleus is so small, um, and uh, and in order for an atom to be electrically neutral, which it must be, it must have the same number of protons and electrons. Now, in terms of how do you find out what these numbers are, you look at your periodic table, and in your periodic table, each element has got an atomic number. The atomic number tells you how many protons are in its nucleus, and therefore, if an atom, for example, has 12 protons, we know that that atom will also have 12 electrons for it to be electrically neutral. So all the atoms that there are in the universe are listed in the periodic table. And when you look at the periodic table, there's about 100 or so atoms that we have available. But we know that there are more than 100 or so types of material. And therefore, all the other substances are made by combining these atoms in various ways to make different compounds. And just at the bottom there in red, we've got the definition of what an atom is. So an atom is the smallest electrically neutral particle of an element that can take part in a chemical change. So that's how we now define atoms. So here's our periodic table, which shows all the elements that we can play around with, which is all the atoms we can play around with. And as you can see, there's not a huge number that we can use, but all the compounds that we have are made by combining these elements together in different ways. So when we combine two different elements together, we form compounds. And that means that we've got atoms, which I've shown on the left-hand side here, and they are bonding, forming a chemical bond here to form a compound. This is with the blue and the red atom joined together. It's a completely new substance that's been made. So that is representing a chemical reaction because new chemical bonds are being made between the blue and the red atoms there. And it's important to realise the difference between compounds and a mixture. So in a mixture, the substances present are not chemically bonded together. So on the left hand side, this is a mixture of two different atoms. I've got blue atoms and red atoms, but they're not chemically bonded together. And on the right hand side, I've got a mixture of a compound and two types of atom. So I've got this compound here, I've got blue atoms, and I've got red atoms. And these three are all they are all different substances. So we've shown a compound being formed there, and the chemical formula is a shorthand method for describing the atoms in a chemical. So, for example, for the previous page, with the blue and the red atoms, that would be one blue and one red atom makes up that compound. The chemical formula of an element or compound, it tells you what elements it contains and how many kinds are in each molecule. So, for example, in iron sulfate here, we have got one iron atom, one sulfur atom, and four oxygen atoms. And for sulfuric acid here, you can see I've got 2 hydrogens, 1 sulfur, and 4 oxygen atoms in each molecule. So I'm sure you've come across polyatomic ions before, but perhaps not heard that term. So a polyatomic ion is an ion like sulfate or nitrate that contains more than one type of atom. So nitrate, you hope to remember from GCSE, contains nitrogen and 3 oxygens and has a charge of -1. And sulfate contains a sulfur and 4 oxygens and has -2. So many of these you'll be familiar with. Certainly the top 6, I imagine. Ones that may be new to you. We've got hydrogen carbonate and hydrogen sulfate. These are really easy to remember. They're just like carbonate and sulfate, but with a hydrogen attached. And because you've added H plus, for example, your charge has gone down from -2 to -1. These are slightly more tricky, and we'll be coming on to these later in the course, but it's quite useful for you to just be aware. Chlorate 1, this is shows what we call the oxidation state of chlorine, and again we'll talk more about that later on. And chlorate 5 there, ClO3 with a -1. If you like, you can think of it that it's the charge that chlorine has, but we'll talk about more about that when we come to look at oxidation states. But those are useful ions for you to just be aware of for the time being. And you'll also see you've got nitrite and sulfite, more on those later on as well. But they are basically the same as the nitrate and the sulfate with -1 oxygen atom. So let's have a look now at how we name inorganic compounds. So, first rule, if there are only 2 elements present, then the name ends in "ide". So, if you've got oxygen, it becomes oxide, chlorine becomes chloride, bromine becomes bromide, iodine becomes iodide, and so on. If hydrogen and nitrogen are present, then hydrogen becomes hydride and nitrogen becomes nitride, like so. So the hydride you can think of as being H minus, like so, when it's combined with a metal like lithium. So it would be like an ionic substance of LiH with lithium with +1 and hydrogen -1. And then you have magnesium nitride there as well. So this works for all the different elements in the periodic table. The non-metals become "ide". The only exceptions are hydroxides and cyanides. Hydroxides are the OH group and cyanides are the CN group. And the charge on those ions, as you'll see on the last page, OH is OH minus and CN is CN minus. The other rule is if the elements concerned could have more than one charge, then we have to show which one it is. So you may remember that iron can have a charge of +2 or +3. So if I just said to you, go and get me some iron chloride, please, you wouldn't know whether to get me iron 2 chloride or iron 3 chloride, and therefore I would need to specify the name and say iron 2 chloride if I wanted FeCl2 or iron 3 chloride for FeCl3. They're 2 different compounds, very different properties, and it's all to do with the charge on the iron ion. So if my compound contains 2 non-metal atoms, then the name needs to say exactly what's in the molecule. So CO is carbon monoxide. Mon, of course, means 1, with carbon dioxide being CO2. And hopefully you can see the rest are pretty straightforward. So you just have the first non-metal there, carbon tetrachloride will have 1 carbon and 4 chlorine atoms. And as you know, when we've looked at polyatomic ions, if the compound contains a metal, a non-metal, and oxygen, the name ends in either "ate" or "ite", depending on whether it is a sulfate a nitrate or sulfite and nitrite. Those are the ones you need to watch out for. So we'll look at this in more detail later on, but sulfite and nitrite are the old-fashioned names for NO2 minus and SO3 2 minus. Just to confuse things further, sulfite and nitrite, they're the old names for those polyatomic ions. The new names are sulfate 6 for SO4 2 minus and sulfate 4 for SO3 2 minus. And for the nitrate and nitrite, we say nitrate 5 for NO3 minus and nitrate 3 for NO2 minus. So later on in the course, when you look at oxidation states, you'll understand where those names come from, but those are the names that we really should use. Generally, however, we for SO4 2 minus we just use sulfate, and for NO3 minus we use nitrate. And if we need to distinguish, we would put nitrate 3 or sulfate 4. So there's just a little summary table of those polyatomic ions. So the common name and the systematic name. So the systematic name is what we should use in our exams, and the formulae are shown there as well. And I just pop the charges there as well. They're all -1, nitrates and chlorates, apart from the sulfates are -2. So going back to our rules, when we're looking at a compound, we generally put the metal first in the name and the formula. The only exception to that is when we come to organic chemistry, and things get a little bit more complicated. Although we put the metal first in the name, we actually generally put it last in the formula, as you can see for sodium ethanoate there. We've already come across ammonium ion, which is NH4 plus. So that NH4 plus can, rather than a metal being a compound, it can be NH4 plus instead. And so we show it like so. So ammonium chloride is NH4Cl and so on. And you can see how we write the formulae for those. You just got to be very careful you don't confuse it with the compound ammonia. And there are obviously some molecules which just don't follow any of these rules at all. The most common one is water, of course, which is H2O, and then you've got your three acids there, sulfuric acid, nitric acid, and hydrochloric acid, which are the formulae shown there, and ammonia as well, which is NH3. So organic compounds, they have their own set of rules for how we name them, which we will come on to when we start studying them at AS. But generally, the one at the moment, you just need to be aware that for organic compounds, they don't follow these rules that we've talked about. Generally, the first four, we look at how many carbons are in the molecule, and if there's one, it starts with meth, 2 eth, 3 prop, and 4 but. They're all a bit weird. After that, it gets a little bit more sensible and starts following in a more logical way of C5 being pent and C6 being hex and so on. So on the next couple of slides are some examples for you to have a go at how to name them. And if you follow the link in red, you will be able to download this as a worksheet and print it off if you like, or do it online. And also the answers will be attached. So that's the first page, and there's the second page, like so. And we are now going to go through the answers on the next page. You may well need to go back and look at that table of polyatomic ions. That's absolutely fine. And obviously you need to use your periodic table for some of these symbols. Pb is of course lead, which you may not know, but so certainly do use your periodic table so you'll work those out. Some of the organic compounds again could be a little bit tricky for you, so don't worry too much about those, but try and work it out if you can, so that you're starting to get to grips with these names. Again, 55 will be a little bit tricky, but you may be able to work that out for yourself. See how you get on. So on the next couple of slides, we will go through the answers, and again, they're on the worksheet. So most of them follow the rules. They should be quite straightforward for you to work out, certainly on this first page. Don't forget for iron there, you do need to put the charge on the iron. That's either 2 or that was 2 for both of 29 and 30, but then becomes 3 later on. So lead is also a variable charge, and copper. Zinc doesn't vary its charge, it's always +2. So don't worry if you did put a 2 there, but actually zinc you will come to know as only ever being +2, and silver in a similar manner can only form silver plus ions. Okay, the validates may have caught you out a little bit, but hopefully you managed to have guess your way through those, and you're now a little more comfortable with how to name compounds. Obviously, for 50, we put sodium nitrite. You could have put instead the systematic name for that one too. So now that you can name compounds from the formula, we're going to try and go the other way in the next video, and we will try giving you the name and writing the formula down from that. So that will follow on the next video.